Find the cardinal number of each of the following sets. Assume the pattern of elements continues in each part in the order given. Now remember, the cardinal number is the amount of numbers that are in that particular set. So for the first example, we want to find out what are the amount of numbers that are in this set. So the first thing we need to do is we can determine, okay, what is the first element in this set? Well, first of all, is this an arithmetic sequence or a geometric sequence? Well, we can see it's an arithmetic sequence. So the first number in this set is 201. We know that the nth term is 1100, and the common difference is equal to 1. Okay, and then remember that the formula is A subscript n, which is equal to the first term, and then plus n minus 1 times the common difference. So now if we plug in our numbers, we have 1100, which is equal to the first term, 201, plus the value of n minus 1 times 1. So we get 1100, which is equal to 201. If we distribute that 1, we get plus n minus 1. And therefore, by combining like terms, we get 1100, which is equal to 200 plus n. Subtracting 200 to both sides, therefore n is going to equal 900. So 900 would be the cardinal number for this particular set. Okay, for the next question, we have 1, 3, 5, all the way to 101. So this is an arithmetic sequence where our first term is equal to 1, our nth term is equal to 101, and the common difference is 2. So again, using that formula, A subscript n, which is equal to A subscript 1 plus n minus 1 times the common difference. So we have 101, which is equal to the first term, which is 1, plus n minus 1 times the common difference. So we have 101, which is equal to 1, plus distribute the 2, we get 2n minus 2. So we get 101. Combining like terms, we get 2n, and then 1 minus 2 is minus 1. If we add 1 to both sides, we get 102, and that's equal to 2n. And then solving for n, dividing both sides by 2, we get 51. So therefore, 51 is the cardinal number for that set. Okay, the next example, we have the following. We have 1, 2, 4, 8, 16, 1024. This we can see is a geometric sequence. Since this is a geometric sequence, we can see that the first term is equal to 1. We know that the nth term is equal to 1024, and the common ratio is 2. Remember, the formula for the geometric sequence is an, which is equal to the first term times r to the n minus 1. So we know that A subscript n is equal to 1024, and this is equal to the first term times r, which is 2 to the n minus 1. So therefore we have 1024, which is equal to 2 to the n minus 1. And so we need to find this number that it has the same base as 2. Well, that's the same thing as saying 2 to the 10th power, which is equal to 2 to the n minus 1 power. Now, since they both have the same base, we can let the exponents equal to each other. So 10 is going to equal n minus 1. Adding 1 to both sides, then n is going to equal 11. So that means 11 is the cardinal number for that set. Now, for D, we have x such that x is equal to k cubed, where k is equal to 1, 2, 3, all the way to 100. Well, if they're saying that k is equal to 1 all the way to 100, it's already telling you how many numbers there are that's going to be in there. Well, if you plug in 1, that's going to be one number. If you plug in 2, that's going to be one number. If you plug in 3, that's going to be the third number, all the way to 100. So therefore, the cardinal number in this one is equal to 100.